Hello, and thank you for your interest in analysis NMR technology and its use within flow systems. In this video, we will look at what hardware comes with the NMReady-flow kit and how to install it on the NMReady-60E spectrometer. Okay, let's go through the kit inventory. Each flow cell kit is comprised of the following pieces: 2 borosilicate glass flow cells, only one is shown in this image, a top cap adapter, a bottom plug adapter, a reducing union for connecting the top of the flow cell to chromatography tubing, a flat-headed nut, a 90-degree connector to connect the bottom of the flow cell to chromatography tubing, and the appropriate ferrules. Let's now go through the 10-step installation procedure. We show you how to install this on an NMReady-60E, but it's the exact same process for the NMReady-60 Pro. I'd like to introduce you to Dr. Juan Arenada, who will be performing the installation. We start off by removing the white cap on top of the spectrometer by unscrewing it. Replace it by screwing in the longer black adapter that came with the flow kit. This provides more support to the flow cell and helps prevent it from being accidentally broken. Next, flip the instrument 90 degrees onto its back. The instrument has a flat back so it can rest on the table in position as long as you are careful to not accidentally tip it over. Once it is on its back, you need to remove the bottom black stopper in the base of the instrument and replace it with the bottom flow adapter provided in the kit. Next, pick up the flow cell. Although reinforced glass, it should be handled cautiously so as not to accidentally break it. The flow cell has been designed with the appropriate dimensions to slide directly through the instrument. Insert it gently until you are sure it has cleared all of the probe material. You will be able to see it stick outside the base. From here, take a flat-headed nut from the kit and slide it until it is connected into the bottom adapter. Once it is in, you can fit the appropriately sized ferrule over the flow cell, tapered side into the hex adapter, and then screw on the bottom 90-degree fitting. This can either be an elbow or modified T-joint. Once it is tight, you can gently wiggle the flow cell and see corresponding movement at the base. This indicates it is fully sealed. From here, you can connect the chromatography tubing. You can use whatever size you like. For our demonstration today, we will use 1/16 inch diameter tubing. We typically use this size to minimize the volume of reaction mixture in the flow cell as opposed to in the reaction vessel. To connect the top of the flow cell, we now reorient the instrument, making sure not to crush the tubing under the anti-vibration feet of the spectrometer. We will use a reducing union, sliding the smaller 1/4 inch piece onto the flow cell and adding a collapsible ferrule before adding the top piece. It will be a tight fit. Now you can take the reducing union, putting on the nut, the collapsible ferrule, and then the reducing union, and gently screwing it closed using your fingers for support. Once it is connected, you now have a sealed vessel around the glass tube, and you can connect the chromatography tubing to the top to complete the loop. For this demonstration, we are using a metering pump, so we will first route the tubing from the reaction vessel to the in port of the pump. By the way, you could use an HPLC pump or syringe pump depending on your personal preference. Now we connect tubing from the out port of the pump to the base of the spectrometer using the tubing we've already hooked up. The tubing from the top of the spectrometer can be connected to a waste vessel or back into your original vessel, again depending on your personal preference. Now we are ready to start flowing the reaction mixture through the spectrometer. With the pump, we have set it up to flow at 1 milliliter per minute. When we start the pump, you'll see red food coloring begin to flow through the tubing into the metering pump destined for the bottom of the flow cell. The speed will, of course, depend on the flow rate and the size and length of your tubing. For the purpose of this demonstration, we are flowing a 1-to-1 mixture of acetone and methanol. Before you can begin acquiring data, we must wait until the liquid has moved into the coil region so it can be excited and detected. The best way to observe when a sufficient time has passed is to use the spectrometer manual shimming window accessible under the Setup button. This gives you a real-time view as to what is happening at the coil. When there's mostly air in the cell, this screen will primarily show noise. In our case, we do see a weak signal from the residual acetone we use to wash out this flow cell before the demonstration. Also, as the cell starts to fill, you will see some broadening effects of the acetone methanol-based solution. But as the filling completes and the active volume is uniformly filled with solution, the peaks will become nice and narrow as you would expect. With the setup here, it took us about 45 seconds to fill the flow cell, but this can be optimized to reduce lag time and speed up first point measurements. Regardless, once the coil volume is filled, you can immediately start acquiring data. This can be done manually by setting up your experiment and simply hitting the Go button. Alternatively, you can use our Kinetics module or even our API for application developers to further customize your experiments. If you are interested in any of these advanced features, please contact your sales representative. Thank you again for your interest in the NMReady-flow kit. You can contact us about the flow kit and our other products by visiting our website, sending us an email, or even giving us a phone call.